Motion and Time. Class 7, Chapter 9. Let's learn, improve your pronunciations. In Class 6, you learn about different types of motions. You learn that You learn that motion could be along a straight line, it could be circular or periodic. Can you recall these three types of motion? Table 9.1 given some common example of motions. Identify the types of motion in each cases. Some example of different types of motion. Example of motions. Types of motion. Soldiers in a march past, bull cart moving on straight road, hands of an athlete in race, paddle of bicycle in motion, motion of earth around the sun, motion of swing, motion of pendulum. It is a common experience that the motion of some object is slow while that of some others in is fast. Slow or fast, we know that some bicycles move faster than others. Even the same bicycle may move faster or slower at different times. Make a list of 10 objects moving along a straight path. Group the motions of these objects as slow and fast. How did you decide which object is moving slow and which one is moving fast? If bicycles are moving on a road in the same direction, we can easily tell which one of them is moving faster than the other. Let us look at the motions of bicycle moving on a road. Look at a figure 9.1 show the position of some bicycle moving on a road in the same direction at the some instant time. Now look at figure 9.2 it show the position of some bicycle after some time. From your observations of two figures, answer the following questions. Which bicycle is moving the fastest of all? Which one of them is moving the slowest of all? The distance moved by the object in a given interval of time can help us to decide it which one is faster or slower. For example, imagine that you have gone to see off your friend at the bus stand. Suppose you start pedaling your bicycle at the same time as the bus began to. Bicycle moving in the same direction on a road. Position bicycle show the after some time. Move the distance covered by you after 5 minutes would be much smaller than that covered by the bus. Would you say that the bus is moving faster than the bicycle? We often say that a faster bicycle has higher speed in 100 meters race. It is easy to decide whose speed in this highest one who takes shorter time to cover the distance of 100 meter has the highest speed. You are probably familiar with the world speed in the example given above. A higher speed seems to indicate that a given distance has been covered in shorter time or larger distance covered in given time. The most convenient way to find out which of the two or more objects is moving faster it is to compare the distance moved by them in a unit time. Thus, if you know the distance covered by two buses in 1 hour, we can tell which one is faster. We call the distance covered by an object in a unit time as the speed of the object. When we see that a car is moving with a speed of 50 kilometers per hour, it implies that it will cover a distance of 50 kilometers in 1 hour. However, a car seldom moves with a constant speed for 1 hour. In effect, it starts moving slowly, then picks up speed. So, when we see that the car has a speed of 50 kilometers per hour, we usually consider only total distance covered by it in 1 hour. We do not bother where the car has been moving with. A constant speed are not during that hours. The speed calculated here is actually the average speed of the car in this book. We shall use the term speed for average speed. So for us speed in the total distance covered divided by the total time taken, thus speed total distance covered total time taken. In everyday life we seldom find project moving with consistent speed over long distance or for long durations of time. Of the speed of an object moving along a straight line keep changing its motion is said by non-uniform. On the other hand, an object moving along a straight line with a consistent speed is to be the uniform motions. In this case, the average speed is the same as the actual speed. We can determine the speed of given object when we can measure the time taken by its cover certain distance. In class, you learn how to measure distance, but how do we measure time? Let us find out. Measurement of time. If you did not have a clock, how would you decide it what time of the day it is? Have you ever wondered how our elders could tell the approximate time to the day by just looking at the shadows? How do we measure time interval of a month, a year? Our ancestors noticed that many events in nature repeat themselves after definite intervals time of, for example, they found that the sun arises every day in the morning. The time between one sunrise and next was called a day. Similarly, a month was measured from a new moon to next. A year was fixed the time taken by the earth to complete one revolutions of the sun. Often we need to the measures interval of time which are much shorter than a days. Clocks or watches are perhaps the most of common time measuring devices. Have you ever wondered how clocks and watches measure times? The working of clocks is rather complex, but all of them make use some periodic motions. One of the most well-known periodic motion is that of a simple pendulum. Well, clock, table clock, some of common clocks. A simple pendulum consists of a small metallic ball or piece of stone suspended from the rigged stand by the thread, figure 9.4. The metallic ball is called the boom of the pendulum. 9.1 show the pendulum at a rest in the main positions when the boom of the pendulum is released after taking it slightly to one side. It begins to move to and fro. The motions of simple pendulum is an example of periodic and oscillatory motion. The pendulum is said to have complete and oscillations when it's bound, starting from its mean position O moves to A to B and back to O. The pendulum also complete one oscillations when its bomb moves from one extreme position A to the other extreme position B and comes back to A. The time taken by the pendulum on complete one oscillation is called its time period. Activity 9. Set up single pendulum as a shown in figure 9. With a thread or string of the length near 1 meter which switch off any fans nearby. Let the bomb of the pendulum comes to rest at its mean positions. Mark the mean position of the bomb on the floor, blow off it or the wall behind it. To measure the time period, the pendulum we will need to stopwatch. However, if a stopwatch is not available, a table, clock or wristwatch can be used. To set the pendulum in motion, gently hold the bomb and move it slightly to one side. Make sure that the string attached to the bomb is a taut while you deplaced it. Now release the bomb from its replaced positions. Remember that the bomb is not to be pushed when it is released, not the time on the clock. When the bomb is at the main position, instead of the main positions, you may note the time when the bomb is at one summit extreme position. Measure the time the pendulum takes the complete 20 oscillations. Record your observations.